Good afternoon to everyone. I'm Srishti and Govinda Gowda presenting you today HSI to RGB conversion. This presentation will delve into the fundamentals of conversion of HSI, hue, saturation, and intensity color space to RGB, red, green, blue color space. We'll explore the underlying mathematical principles, examining the advantage of using HSI over RGB and specific image processing tasks. The presentation will cover the step-by-step process of conversion, including illustrative examples and practical applications across various fields. We will also explore examples, implementations in Python and MATLAB. Fundamentals of digital image processing. Image representation. Digital images are composed of pixels, each with very specific color value. These pixels are arranged in grid-like structures, forming the spatial images representation. The resolution of an image determines the number of pixels and hence the level of detail. Higher resolution images contain more pixels, resulting in sharper and more detailed visuals. Different formats like JPG, PNG, TIFF are stored pixel information differently, affecting size, image size, and quality. Color models. Different color models like RGB and HSI represents color in various ways. RGB, that is red, green, and blue, is an additive color model where colors are created by combining varying intensities of red, green, and blue. HSI, hue, saturation, and intensity, is a more perpetual uniform model separating color information hue from intensity and saturation, making it useful for image processing tasks. Other models like CMKY, can, magenta, yellow, key, or black are used primarily in printing. Image processing. Techniques like filtering, enhancement, segmentation, manipulating pixel values, filtering smooth or sharpened images by average or emphasizing pixel differences. Enhancement techniques will improve image quality by adjusting contrast, brightness, or even sharpness, segmentations, partitions, and image into meaningful regions based on similarities and pixel characteristics. These techniques are foundations to many applications in computer vision and image analysis. RGB and HSI color models represents colors in a combination of red, green, and blue intensities. Represents color using hue, saturation, intensity, more intrusive for human perception. Advantages of HSI over RGB. Perpetual understanding. The HSI color models aligns more closely with human color perceptions than RGB. Humans naturally perceive color in terms of hue, the dominant color, saturation, the intensity of color, and intensity brightness. This inherent alignment makes it significantly easier for humans to interpret and manipulate color information in the HSI space, leading to more intrusive image editing and analysis. Tasks like color correction and adjustments become much simpler and more predictable. HSI offers significant advantages in image processing tasks due to its separation of color information from intensity. Color segmentation, a crucial step in many image analysis, application becomes more robust and accurate in HSI because hue, saturation, and intensity are independent. You can isolate and modify specific color characteristics without affecting the overall brightness or saturation of the image. This allows for more precise controlling over image enhancement, objective recognition, and other color-based image manipulations, leading to improved results. Step 1. Separate the RGB and channels. That is, first is red channel. Isolate the red component of the image. Isolate the green component of the image. Isolate the blue component of the image. Step 2. Calculate hue, saturation, and intensity. Hue represents the color position of the color wheel. Saturation indicates the purity or vividness of the color. Intensity defines the overall brightness of the color. Convert HSI to RGB. HSI to RGB conversion. These steps involve transforming the calculation hue, H, saturation, S, and intensity I values back to their corresponding red R, green G, and blue B components. This is achieved using mathematical formulas specifically designed to handle the nonlinear relationships between HSI and RGB color spaces. Substep, handling the hue. The hue value represents the color positions and the color wheels needs to be adjusted based on the range, typically 0, 360. Formulas may involve different expressions depending on the hues quadrant to properly map it to R, G, and B values. The sub-step, saturation and intensity. Saturation and intensity are incorporated into RGB calculation. S controls purity and I determines brightness. These components modulate the contributions of each RGB component, creating values in the color vividness and intensity. The sub-step, applying formulas. The final step to apply the relevant mathematical equations that contribute the HSI and I derived to corresponding RGB value. These usually precise functions which consider the difference of H. Mathematical formulas for HSI to RGB conversions. The hue calculation depends on the range of HSI values. Specifically, formulas often use precise wise functions to account for the cyclic nature of the hue, that is 0 to 360 and map it correctly to RGB components. The quadrant of the hue falls into distinct and specific equations used. Saturation and intensity directly affects the final RGB values. These are often multiplicative factors that modulate the R, G, and B components obtained from the hue calculation, a higher saturation values resulting in more vibrant colors, while intensity adjusts to the overall brightness. RGB value derivation. The final equation combines the adjust hue, saturation, and intensity to calculate the corresponding RGB values. These equations are derived from the relationship between the HSI and RGB color spaces, ensuring a smooth transition between these color models. The example implementation in Python MATLAB is one of the libraries used in the HSI to RGB conversions. Practical applications of HSI to RGB conversions. Image enhancement, adjust the brightness, contrasts, and color balance, color segmentation, separation different colors in an image for analysis. The object recognition, identifying objects in an image based on their colors characteristics. Thank you.